A P-MOSCAP has a P-type semiconductor as substrate. A MOSCAP consists of metal, oxide, and semiconductor. Regions of operations are accumulation, depletion, and inversion. In accumulation region of operation, positive is connected to the substrate and negative to the metal. So that makes the electrons flow from the substrate to the metal. The electrons are pulled from the semiconductor and this leaves holes behind. The electrons start accumulating over the metal and holes start accumulating near the oxide semiconductor interface due to the applied external bias. As the bias is increased, more electrons and holes are accumulated. As we move from the bottom to the oxide semiconductor interface, the semiconductor becomes more P-type. This region near the oxide semiconductor interface is called as accumulation region. Looking at the band diagram, the right side of the substrate is P-type, and as we go up nearer to the oxide semiconductor interface, the substrate becomes more P-type. So keeping the Fermi level as the reference level, as we go nearer to the oxide semiconductor interface, the Fermi level goes nearer to the valence band. Nothing interesting happens in the accumulation region of operation because the MOSCAP acts like a regular capacitor. In depletion region of operation, the polarity is reversed, which makes the electrons move from metal to the P substrate. As the electrons come from the metal, this leaves holes behind. The electrons from the metal recombine in the P substrate and forms immobile ions near the oxide semiconductor interface. As the external bias is increased, a layer of immobile ions is formed, so forming a depletion region. On further increase in external bias, the depletion region grows to a certain width, after which no recombination occurs. This width is the maximum width of the depletion region and it determines the threshold voltage. As we move from the bottom of the semiconductor to the oxide semiconductor interface, the semiconductor becomes less P-type. Looking at the band diagram, as we go nearer to the oxide semiconductor interface, the substrate becomes less P-type, so the Fermi level goes away from the valence band. This region of operation is called as depletion region of operation. Inversion region of operation. The inversion region of operation occurs only after the depletion region of operation. As the recombination stops, the electrons start accumulating near the oxide semiconductor interface, which is the depletion region, thus acting as the majority charge carriers, and thus this region becomes N-type. As we move from the bottom to the oxide semiconductor interface, the substrate becomes N-type. Looking at the band diagram, as we go nearer to the oxide semiconductor interface, the substrate becomes N-type, thus the Fermi level crosses the intrinsic Fermi level and goes nearer to the conduction band. This region of operation is called the inversion region of operation. This inversion region of operation is only available when the external bias is greater than the threshold voltage.